This lecture video is the second part of section 4.4 or activity 4.4, and what we're going to do here is solve some quadratic equations. So we'll start off with some easier equations and then build up to some more difficult ones. So our first example, we have a squared equals 36. So to unsquare something, remember what we do to both sides is we take the square root. And so the square root of a squared is a, and the square root of 36 is, when we do the square root on both sides, we have to remember to do the plus or minus, so it would be plus or minus 6. And again, the reason that we do plus or minus is because if you square 6, you get 36. But also, if you square negative 6 times negative 6 is a positive 36. So we don't know if the number that I squared was positive 6 or negative 6 to get the 36, and so we have to consider both possibilities. In this next one, we have 2x squared plus 98. Before you can do the square root thing, you need to have this x squared by itself. So the first thing that we need to do is divide both sides by 2. And we get x squared is equal to 49. And now that we have the x squared alone, we can take the square root on both sides, and we get x is equal to plus or minus 7. The next one, same thing. We have a 3 in front of the x squared, so I need to divide both sides by 3. And we get x squared is equal to, let me just do that one on my calculator. 375 divided by 3 gives me 125. And then we want to take the square root on both sides. And so we get x is equal to plus or minus the square root of 125. And we want to round decimal results to the nearest hundredth. So I want to take the square root of this, and that gives me 11.180. And after the 0 is a 3, so I'm going to leave it as 0.180. And our last one here, we have 5x squared equals 50. So we need to divide by 5 on both sides. That gives me x squared is equal to 10. And then we would take the square root on both sides, giving us x is equal to plus or minus the square root of 10. And we want the 3 decimal place result there. So type in a 10 and take the square root of that, and I get 3.162. And immediately following the third decimal place, oh, I want to round this to the hundredth, so that would be 3.16. So plus or minus, 3.16. And this one we only wanted it to 2 decimal places, so 11.18. And this one needs its plus or minus symbols. So plus or minus 3.16. In these next ones, how many solutions do each of the following have? So we have 16x squared equals 100. So this will have 2 solutions. Just like the problems up above had 2 solutions, this will also have 2 solutions. We would divide both sides by 16. And we'll just leave it as x squared equals 100 divided by 16. And then we could take the square root on both sides. And when we take the square root on both sides, we would get x is equal to plus or minus 10/4. And that would be plus or minus 5/2 if we simplify it down. And their next one is 16x squared equals 0. Well, now if we divide both sides of this by 16, we'll have x squared equals 0. 0 divided by any number is 0. And when you take the square root of 0, you just still get 0. And there is no plus or minus with 0. So this one only has one solution. And I forgot to write the word 2 here, so 2 solutions there, 1 solution for the middle one. In this last one, if we divide both sides by 16, we get x squared equals, and we have negative 96, and we're dividing that by 16, which gives us negative 6. And you can't take the square root of a negative number. There's no number. Remember, whenever you square something, it's always positive. So this has no real solutions or no solution. Okay, so just be careful of that. You can't take the square root of a negative number. So that would give you no solution in that case. In our next one, we have 5x squared equals 20. So we're going to start off dividing by 5 just like we did before. So that gives me x squared equals 4. And then we're going to take the square root on both sides. And we get x is equal to plus or minus 2. The next one, divide both sides by 4. We get x squared equals 0. And that would just give us x equals 0. In our last one, divide both sides by 3. We get x squared equals negative 4. And you can't take the square root of a negative number, and so there's no solution. Next, we're going to solve equations that have the form x plus a squared equals c or x minus a squared equals c. So this time, the difference between what we were doing before and now is that we have this quantity being squared. And so we're going to do the same process. To unsquare that quantity, we would take the square root on both sides. So we take the square root on both sides. And the square root and the square cancel each other out, leaving you with x plus 4. And again, remember when you do the square root on both sides, you have to do plus or minus 3. So this basically leaves you with 2 equations to solve. The 2 equations are x plus 4 equals positive 3, and x plus 4 equals negative 3. When I solve the first one, we would subtract 4. And 3 minus 4 is negative 1. Solving the other one, subtract 4 from both sides, and we get x is equal to negative 7. So we get 2 solutions, negative 1 and negative 7. The next one, same thing. We have this quantity being squared equals 25. So we're going to take the square root on both sides. That will leave us with x minus 1. And it equals plus or minus 5. So we have 2 equations, x minus 1 equals 5, and x minus 1 equals negative 5. To finish solving, we add 1 to both sides of the first equation. That gives us x equals 6. Then add 1 to both sides of the other equation, and it gives us x equals negative 4. So we have 2 solutions, x equals 6 and x equals negative 4. So if you wanted to pause the video, you could go ahead and do that and try these last 2 on your own, and then start it up and check and see if you did them correctly. So to start this off, we have x plus 5, that quantity squared equals 100. So I'm going to take the square root on both sides. I get x plus 5 is equal to plus or minus 10. And my 2 equations are x plus 5 equals 10, and x plus 5 equals negative 10. Subtract 5 from both sides. We get x equals 5. Subtract 5 from both sides of the other equation, and we get x equals negative 15. So our 2 solutions are 5 and negative 15. Our next one here, so we do the same procedure. Take the square root on both sides. We get x minus 10 equals plus or minus the square root of 70. gives us two equations, x minus 10, and I'm going to take the square root of 70 and just use that as a decimal number. And that would be 8.3, and the number after this, 6, is a 6, so we're going to round that first 6 up to a 7, so 8.37. So now set up our two equations. We have x minus 10 equals 8.37, and x minus 10 equals negative 8.37. Now add 10 to both sides, and we get x is equal to 18.37. And add 10 to both sides of this equation, and we get x is equal to 1.63. And I believe this is, oh no, we've got a couple of solving problems at the end. So here's a word problem. Suppose you have a 10-foot by 10-foot square garden plot. This year you want to increase the area of your plot and still keep its square shape. Write an expression for the length of the side of the larger square. So right now we have a garden, and it's 10 feet by 10 feet. We want to add on to this so that we still have a square. So I'm going to add on here. And whatever I added on up here for the length, I need to add down here to the width. And I want to just make sure that I maintain a square. So I added on some length over here, and I want to add that same length on over there. So this length, let me see if I can get from right here to right here is 10 feet, and this is x feet. So this total length is this 10 feet plus this x feet. So this side is x plus 10, this 10 feet plus this x, and over here, this is 10 feet, and this is x feet, and so this is also x plus 10. Remember, I want to maintain the square shape. So write an expression for the length of the side of the larger triangle, and so that would be this x plus 10. Express the area A of your new larger plot as a square of a binomial in function notation. So I used x for my unknown length, and so that would be a of x equals, the area of a square, remember, is a equals s squared, the side squared, so that would be the quantity x plus 10 squared. Suppose you decide to double the original area. Use the area expression to write an equation to determine the required increase in the length of each side. So I want to double my area. My original area for my 10 by 10 foot garden is 10 times 10, or 100. Oops. If I want to double that, that would mean I would want 200 square feet. So my new area then would be 200, and that would be equal to the quantity x plus 10 squared. Now solve this equation. So to solve this, I want to take the square root on both sides. And we have the square root of 200, and that would be plus or minus, and that's going to be equal to x plus 10. Now take the square root of 200, and we get 14.14. So that gives us two equations. x plus 10 equals 14.14, and x plus 10 equals negative 14.14. We would subtract 10 from both sides, giving me x equals 4.14, and that's feet. And do the same thing here. Subtract 10, and we get x is equal to negative 24. So this one we don't want to consider because the x is a length, and we can't have a negative length. So we would want to add 4.14 feet onto our original garden. What is the length of each side of your new garden to the nearest tenth of a foot? So we would take the part that we're going to add on and add that to 10. So it would be 14.14 feet. So now we just have a couple others to solve. They're just a little bit different than the ones that were in your textbook. So these are not in your book. These are some extra examples that we are going to go over. So in this first example, we have 6 times the quantity x minus 2 squared equals 294. So we need to get this thing that's being squared alone first. So the first thing that we need to do here is to divide both sides by 6. And 294 divided by 6 gives me 49. So I have x minus 2, the quantity squared, equals 49. And now that we have this quantity being squared by itself, you can take the square root on both sides. That leaves us with x minus 2 equals plus or minus 7. And we have two equations, x minus 2 equals 7, and x minus 2 equals negative 7. Add 2 to both sides. The first one gives us x equals 9. And add 2 to both sides of the other equation gives us x equals negative 5. In our next one, we already have the quantity being squared by itself, so we can go ahead and take the square root right away. That leaves us with 3x minus 8 equals plus or minus 11. Now, this gives us two equations, 3x minus 8 equals 11, and 3x minus 8 equals negative 11. Solving the first one, we would add 8 to both sides, giving us 3x equals 19, and then divide by 3. We get x equals 19 thirds. And you can just go ahead and leave that as a fraction, unless when you're working on MyMathLab it asks for a decimal, then you would want to go ahead and divide it. And so you would give 6.33. On a test, I would be fine with you leaving it as 19 thirds. And our last one, so here again we want this 7 plus x squared, that quantity, or 7 plus x, the quantity squared, to be alone. And we're subtracting 15 from it right now, so we would need to add 15 to both sides so that we'd have this quantity by itself. So that will give us 7 plus x, the quantity squared, equals 100. And now that we have the quantity squared alone, we can take the square root on both sides. And the square root and the square cancel each other out, leaving you with 7 plus x. And the square root of 100, remember to do the plus or minus. So plus or minus 10. So our two equations are 7 plus x equals 10, and 7 plus x equals negative 10. Subtracting 7 from the first equation gives us x equals 3. And subtracting 7 from the other equation gives us x equals negative 17. And that is the end of this lecture. If you have any questions, let me know. Thank you.